Okay, so now we're on to opposites because it's going to lead into subtraction. So that's why I want to separate into a new video. All right, so opposite. A number's opposite just is the number with a negative sign in front of it. Okay, so if you think of like a number line, you think of your 0 as kind of like the mirror, where, you know, and when you look in a mirror too, it's got like depth perception, right? So you can see the ones closer to the mirror, and so then there's the negative one kind of reflecting off of it that you see into it, right? And 2, -2, and you get that depth perception, 100 and -100. Those numbers represent their opposites. Okay, so 5, -5, 10, -10. When we get to multiplication, we'll kind of look at like why -7. Why wouldn't it be like -7? It's actually because the two negatives kind of cancel each other out and you get +7, right? And then -3's opposite is 3, right? So these are just some opposite examples. Okay. And again, we'll be using this a lot later, right? So adding opposites cancels each other out. You get 0, right? So 5 plus -5 gives you 0. 10 plus -10. These are just all the ones that I did right up above. -7 plus 7. They all give you 0. Right? So that leads me into subtraction. Subtracting with negative numbers. But first I want to go over really like what is subtraction, right? Subtraction, you're taking something, you know, taking a number away, you're spending some money and your money goes down, right? You're subtracting your balance. So if we look at these adding the opposites, right? 5 plus -5, we know when we add opposites together, we get 0. We know that when we subtract a number by itself, we also get 0, right? So 5 plus -5 is 0. 5 minus 5 is also 0. Therefore, 5 plus -5 is equal to 5 minus 5, right? 0 will equal 0, right? They both come out the same on either side. So what this means is that subtraction is the same as adding the opposite. What does that mean? So we have 5 minus 5, and instead of saying 5 minus 5, I can add the opposite, right? So I'm changing the subtraction to addition, and I'm changing my second number to its opposite, right? Because we just saw right here, they're the same thing. 5 minus 5 is 5 plus -5. I will get 0. Okay, so I just wanted to do those examples to show you how it is that that they're the same thing. Right? And again, this is going to be one of those things like, why would I change that? That makes no sense. When we start getting variables, it will make sense, especially when, like, say you'll get right, things like this, getting a little bit more complex. Don't worry, you'll get to it eventually. I want to remember the commutative property. I can add in any order. Well, this is an addition right now, right? I have subtraction in there. Well, if I remember my rule, I can do the adding the opposite, right? Instead of minus 12x squared, I can say plus negative 12x squared, right? So on and so forth. And if that's confusing, that's fine. Don't bother with it if it's too much right now. But this is where changing subtraction to adding the opposite starts coming in handy, so that you can use the commutative property, you can change the order of things, and you can really manipulate your problem. So right now it's going to look like really ridiculous. Like, why would I just do it with 6 minus 3? But we're going to do it for simplicity's sake to learn it. Okay, so yeah, 6 minus 3, instead of subtraction, I'm going to add the opposite. So that means 6 minus 3 is the same as 6 plus -3, and we get 3. Right, and if you look at a number line, maybe I should erase it so I can kind of like restart that. Right, so if I were going to subtract 6 minus 3, so if you add, right, you go to the right. If you subtract, you go to the left. I get 3. if I add the opposite, right? If I add a positive, I go to the right. If I add a negative, I go to the left. I still get 3. So you can see I end up at 3, whether I'm doing this one or that one. Right, so that's how you can see subtraction of a positive number. You move left, add a negative number, you move left. So that just even using just a number line, you can see, right, that subtracting is the same as adding a negative. Adding the opposite, sorry. Okay, so 6 minus 8 is equal to 6 plus negative 8, right? And we get negative 2. Just doing examples. This is one of the main reasons, too, why I find it really useful to know this rule. Oops. Because in all these other cases, like all of these up here, it's kind of like, I don't really need to add the opposite. It makes sense to me just fine, just subtracting it, right? But then you get to something like this, negative 3 minus negative 7. That's one of those where it's like, okay, I know what to do when I add a positive number. I know what to do when I add a negative number. I know what to do when I subtract a positive number. What do I do when I subtract a negative number, right? It's kind of like really confusing. So if you just remember the rule, instead of negative 3 minus negative 7, I'm going to instead change it to adding and change the negative 7 to its opposite, right? And then we just get negative 3 plus 7. It's like, oh, it was actually a lot simpler than I thought it would be, right? And then we just get 4. See right here, 10 minus negative 6, right? And so I'll change that to adding, change negative 6 to the opposite, which is positive 6, and then we just get 10 plus 6. It was actually a really simple problem, and it was just written really complicated. Right, and sometimes that happens in real life when you like create formulas and things. It'll be like really complicated, and then that's why you simplify. That's why you know all these rules, so that you can actually find sometimes the really simple answer. Okay, so this is where I find knowing this rule right here, where I find it really useful, because otherwise I'm like, I don't even know where to start with that. So you just remember to add the opposite, and yeah, so because you don't have to do it for things like this, whatever you want to do. All right, so that's subtraction.